Hi, my name is Kanalına van der Hevel and I'm a senior product developer at EV Pharma. Today I'm going to talk about 3D powder bed printing. To be more precise, formulating with a hydrophilic model drug compound. So let's get started. First, I would like to explain a bit about the used technology. In our case, it's powder bed printing. We've used equipment at DNO. And while we watch this short video, I would like to explain a bit more about the technology used. While we look at the video, I will explain you a bit more about powder bed printing and the critical parameters coming with it. First of all, you have the print table, which will be filled with powder and will be smoothed with a counter-rotating roller. This table will move afterwards to the nozzle. It is very important that the layer placed on the bed is really smooth, because if cracks are happening in that blend, they will also appear in your tablet. If your tablet bed is moving to your nozzle, the nozzle will precisely wet a circle of 9 mm or the tablet shape you would like to have. It is important that the droplets will penetrate quickly into your blend in order to ensure a quick printing time. After the wetting of the circle, the blend moves back to the powder hopper, which fills an adjacent layer on top of it. It goes back to the nozzle, wetting the same circle again, and in this way you can really build your tablet. When you are finished, you can just scoop out the wet part of your blend and have your powder bed printed tablet. So, now we tackled the used printing technique, let's go on to the materials. As we've said before, we've used a hydrophilic model compound. In our case, we use acetaminophen at a level of 10%. Besides the API, we also need of course excipients to create your blend to give correct flowability and wettability. We have used lactose, fully pre-gelatinized starch and Primogel. Primogel being sodium starch glycolate. We've used the binder and super disintegrant at a level of 10 and 5%. The next formulation has exactly the same components: lactose, fully pre-gelatinized starch and Primogel, but the difference is that the binder level is now 5% instead of 10. We've based these formulations on previous research, which is published in Powder Technology. Here below you can see the reference, which you can look up freely on the internet. As shown in the video, there are two critical material attributes, being flowability and wettability. Flowability we have determined with a shear cell, and we determined the flow friction coefficients. All blends were easy flowing. The second one was the wettability. We determined that with a drop shape analyzer. All penetration times were quick, being within 5 seconds. So now we've determined that our blends have a good flow, so the print table should be filled correctly and the wetting time is fast. So now we can continue to do some actual print work. And here you can see the result of the first printing trials at DNO. Some nicely powder bed printed tablets. But there's more to a tablet than just appearance. There's also the dissolution and the hardness. Let me guide you through our results. Let's start at the top. The first red line is the line which has 5% of binder level. The orange line at 10% binder level. And if you can imagine, the less binder in your tablet, the less strength there is, so the quicker the dissolution, but the lower the hardness. Besides varying the formulation, we also varied the print setting. We did that with the line spacing. Line spacing is the distance between droplets. So the higher the value here, the further the droplets are apart. If the droplets are farther apart, there's less liquid in your tablet. If there's less liquid, the binder has more problem to bind strongly. So less liquid would mean a quicker and softer tablet. That's also what you see here. The less liquid lines are faster and the more liquid lines are a bit slower, but also a bit harder. So what do we learn from this? We learn that if you optimize your formulation, you have to together with your print settings, because both impact your dissolution and your hardness. And this brings me to the end of the presentation, so I will give you some concluding remarks now. We've determined the critical material attributes, flow and penetration time, and we found that both are suitable for powder bed printing. We've taken a blend to TNO to print tablets, and we found promising results. So a lactose starch blend is capable of printing formulations. We also learned something during that process. We learned that optimizing print settings and formulation have to be in conjunction. And with this, and if you did you get enthusiastic about this presentation and you would like to start a powder bed printing yourself, then please feel free to reach out to us, because DAV Pharma can be your starting point in powder bed printing. And with this, I would like to thank you for your time and I hope to hear from you soon to do some actual printing trials.